Let's continue going on. Very, very similar to the previous problem. The limit as x goes to infinity of 2x squared plus 5 over 3x squared plus 1. So notice they just cranked that power of x up 1. It was 2x, now it's 2x squared. So what happens when we have something like that? Well, again, if we plugged in large numbers, we would get something that goes towards infinity on top, something that goes towards infinity on bottom, which is indeterminate form. So we need a different trick. Again, what was our trick? Our trick was to take every single term, I'm going to leave some space here, 2x squared plus 5 on top, 3x squared plus 1 on bottom, leaving room. I'm going to divide every single one of those terms by the highest power in the denominator. Well, the highest power in the denominator is x squared. So I'm dividing all 4 of those terms by x squared. Now I'm going to simplify each one of those terms individually. So let's think about each one of those terms simplified individually. 2x squared over x squared, well, that just goes to the number 2. So that's the number 2 right there. 5 over x squared, that stays exactly the same. That doesn't simplify. 3x squared over x squared, that simplifies to the number 3. And then 1 over x squared, that doesn't simplify, so we'll just leave that. So on top, I have 2 plus 5 over x squared. On bottom, I have 3 plus 1 over x squared. Now I actually want to evaluate those limits. I want to think of each one of those terms, what they're going to go to. Well, the number 2 is a constant, so that stays the same as 2. 5 over x squared, again, we'd be going towards infinity on the bottom. So 5 over infinity would go towards 0. We have 3 on bottom, that stays the same, and then 1 over x squared. Again, x is getting huge, 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 so a constant over x would approach 0. Now I've evaluated my limit, so I don't need to write the limit sign anymore. On top, I would have a 2 plus a 0. On bottom, I'd have a 3 plus a 0, which is giving me a total of 2/3. So the limit as x approaches infinity of 2x squared plus 5 all over 3x squared plus 1 is 2/3. Again, what does that tell me? That tells me that if I really thought about this, again, this is not the actual problem. I'm just saying, what does this mean? This means y equals 2/3 is a horizontal asymptote. Not the point of the problem, just big picture. We're going to be seeing this later on. Why do we care about that? Okay. Let's look at the last example here. This is the example C. It's the limit as x approaches infinity of 2x cubed plus 5 over 3x squared plus 1. Again, virtually an identical problem, except now I'm cubed on top. So again, if I tried plugging this in, infinity cubed is still infinity, times 2 is infinity, plus 5 is infinity. Infinity squared is infinity, times 3 is infinity, plus 1 is infinity. So here's again where I have that infinity over infinity, which is indeterminate form. So that means I need to do something else. Again, our trick was divide everything by the highest power of x in the denominator. So when I do that, on top I have 2x cubed plus 5, leaving room. On bottom I have 3x squared plus 1, leaving room. I divide each one of those by the highest power in the denominator. The highest power in the denominator is x squared. Okay, the highest power in the denominator is x squared. Now I want to do my simplification and see what happens. So I have the limit as x approaches infinity. I'm going to simplify each one of those terms individually. 2x cubed over x squared simplifies to be 2x. 5 over x squared, nothing I can do there, that's 5 over x squared. 3x squared over x squared, well, that simplifies to the number 3. And then the last one, I have 1 over x squared, which doesn't simplify, so that's it right there, 1 over x squared. So this is the exact same thing as the limit as x approaches infinity of, on top I have 2x plus 5 over x squared. On bottom I have 3 plus 1 over x squared. I'm going to find the limit as x approaches infinity of each one of those. Well, the limit as x approaches infinity of 2x, that would approach infinity, right? 5 over x squared, that's a constant over infinity, so that approaches the number 0. 3 just approaches 3. 1 over x squared, again, that approaches the number 0 because you have a constant over infinity. So again, I've evaluated the limits. I would have something like infinity plus 0 over 3 plus 0. Well, that's infinity divided by 3. And infinity divided by any constant is infinity. So the answer for this one would be infinity. I do want you to notice that it went towards positive infinity. X approached positive infinity. If x approached negative infinity, the answer here would have been negative infinity. So you really, really do have to be careful with your signs on this one. Okay, so we had 3 different cases. I want you to look at cases A, which was on the previous page, B, and C. A, B, and C. I wanted you to see those cases. Well, let me go ahead and rewrite this here real quick, because I want you to see that when we look at problem part A was the limit as x approached infinity of 2x plus 5 all over 3x squared plus 1, right? So it was x to the first power. I'm going to title each one of these things for you. The first one I'm going to title as bottom heavy. So what does bottom heavy mean? Bottom heavy means the degree on bottom is higher than the degree on top. Notice the degree on bottom is 2, the degree on top is 1, so the degree on bottom is bigger, so this is called bottom heavy. The next case that I want you to look at is case B. This is what I call balanced. Balanced is when the degree on top and the degree on bottom are the same. The last case that I wanted you to see was case C. C is what I call top heavy. Top heavy is when the degree on top is bigger than the degree on bottom. So these are the 3 different cases that you could have in these types of problems. Bottom heavy, balanced, and top heavy. What's the trick to solving them? Divide them by the highest power of x in the denominator. Well, when you do that, you're going to start noticing something happens every single time in each one of these 3 cases. So what's happening? And that's what that next chart is about. It says guidelines for finding limits at plus and minus infinity of rational functions. The first one says if the degree of the numerator is less than the degree of the denominator. That is what I called bottom heavy. Anytime your function is bottom heavy, that implies the limit as x approaches plus or minus infinity of your function is always going to equal 0. So you don't have to show all the work. You can simply write bottom heavy. You know the answer is 0. Really, really cool. Number 2 here says if the degree of the numerator is equal to the degree of the denominator. Remember, this is what I call balanced. Then it says the limit of the rational function is the ratio of the leading coefficients. Ratio of the leading coefficients. What does that mean to me? That means take the leading term of the top, the highest power term of top, and divide it by the highest power term on bottom. The highest power term on top divided by the highest power term on bottom. So for instance, 2x squared over 3x squared, the x squareds would simplify and you would be left with 2/3. 2/3 is the ratio of the leading coefficients. Okay? The last one is if the degree of the numerator is greater than the degree of the denominator. This is the one that I called top heavy. And top heavy would say that the limit as x approaches plus or minus infinity, your infinite limits, limits at infinity would be equal to plus or minus infinity. You don't know. The function does not exist, the limit does not exist because it's infinity or negative infinity, but you need to do a little bit more work to decide would it go towards positive infinity or would it go towards negative infinity. So for instance, on this one right here, I look at C. I know that it's top heavy because I have x cubed on top and x squared on bottom. I would need to think, how does it go? Does it go to positive infinity or does it go to negative infinity? Again, what I would do is take the ratio of those leading terms, just the 2x cubed and the 3x squared, and then I would think, okay, so that would be 2x over 3. As x goes to infinity, that would be positive values, so that would go to positive infinity. So really all you care about is those leading terms on top and bottom, thinking about what happens in terms of the sign. All right, let's look at example 4 now. It says, show that the logistic function 1 all over 1 plus e to the negative x has a different horizontal asymptotes to the left and to the right. So what this is saying is we need to investigate the limit as x approaches negative infinity of this function. And we need to approach or look at the limit as x approaches infinity of this function. Okay, so how are we going to do that? Well, let's simply use some charts. Let's look at our x value and our y value. Again, our y value being plugging it into this function, 1 over 1 plus e to the x. And the idea is I need to approach negative infinity. So I'm going to do numbers like, I'm going to start with, I need to plug in at least 3 numbers, about -1, -10, -100. So here I'm really looking at the direction going to the left, right? And the next one I'm going to plug in, how about 1, how about 10, and how about 100? And really here I'm looking at the direction as it goes to the right, towards infinity. So what am I going to do? I'm just going to straight up use my table feature on my calculator. I'll clear out everything that I have in there. I'm going to hit 1, the n over d button, and then in bottom I need to type in 1 plus, I need to do e to the negative x. So that's the second ln button is how you get the e. Make sure you hit the negative sign and then the x. So I have 1 all over 1 plus e to the negative x written in my calculator. I hit enter. Start doesn't matter, step doesn't matter. Make sure you select Ask X, hit OK. And I'm going to start typing in numbers. -1, enter, -10, enter, and then -100, enter. Okay, so what do I get? When I plug those numbers in, -1 I got 0.27, then I got 0.0004, and then I got, it says 3.72 e -44. What does that mean? That means move that decimal to the left 44 times. So that's essentially equal to 0. So as I go to the left, my y values are approaching 0 for sure. Now I'm going to go back in and I'm going to type in the positive values. So I'm going to type in 1, enter, 10, enter, 100, enter. And when I do that, I get 0.73, 0.99, and then my calculator just says, look, it's virtually 1. So as I go to the right, I notice that my y value is approaching 1. So the limit as x approaches negative infinity here is 0, and the limit as x approaches infinity is 1. This is a graph where I have 2 different horizontal asymptotes. Really, really cool example here. Really cool, something to think about here, okay? So what do I encourage? I encourage you to look at the graph of this. If you graph this on your calculator, here's what you're going to see is something like this. Here's a y value of 1, here's the y value of 0. You're going to see something that looks roughly like this, I believe, okay? So we can see as it approaches from the left, sorry, let me use my proper color here. As I approached it going to the left, I approached the horizontal asymptote y equals 0. And as I approached it going to the right, I approached the horizontal asymptote y equals 1. So really cool thing to do here is see that a function can have 2 different horizontal asymptotes.